Implementation of F-47 stealth technology by 2024, full event report. Date, March 21, 2025. Budget allocation, $3.2 billion. Objective, enhance aerial combat capabilities through advanced stealth technology. Overview. The F-47 project, an ambitious military aviation initiative, aims to revolutionize aerial combat by implementing cutting-edge stealth technology by the year 2024. This report outlines the project's structure, detailing the 4 key development phases, budget allocations, and expected outcomes. The project is poised to significantly enhance the stealth capabilities of military aircraft, thus ensuring dominance in modern combat scenarios. Key development phases. The F-47 project is structured into 4 distinct phases, each critical to the successful implementation of stealth technology. 1. Research and Design Phase 1. In this initial phase, extensive research and design activities are conducted. The focus is on utilizing computer simulations to test various stealth configurations, developing prototype models that explore different aerodynamic shapes and materials, identifying the most effective designs that can minimize radar cross-section (RCS). Outcomes. This phase is essential for laying the groundwork for the aircraft's stealth capabilities and understanding the technological requirements before moving on to physical prototypes. 2. Prototype Development Phase 2. Upon completion of the research and design phase, the project transitions into prototype development. Key activities include building scale models of the F-47 for practical testing, conducting tests to refine stealth features and overall aircraft performance, utilizing data from these tests to inform design improvements. Outcomes. Development of the first prototypes is expected to provide invaluable insights that will enhance the aircraft's operational effectiveness. 3. Testing and Evaluation Phase 3. The third phase focuses on rigorous testing protocols, which encompass ground tests to check structural integrity and system functionality, flight trials to assess speed, maneuverability, and stealth performance under various operational conditions. Outcomes. The goal of this phase is to ensure that the F-47 meets or exceeds the specifications set forth in earlier phases, providing a reliable and capable platform for military operations. 4. Production and Deployment Phase 4. The final phase involves the transition from prototype to full-scale production, which includes establishing manufacturing processes and supply chain logistics, planning for the operational deployment of the F-47 within military units, aiming for operational readiness by the end of 2024. Outcomes. Successful completion of this phase will result in the F-47 being a fully operational stealth aircraft within the military arsenal. Budget allocation. The total budget for the F-47 project is set at $3.2 billion. Allocated as follows. Phase 1 Research and Design, $800 million. Phase 2 Prototype Development, $1 billion. Phase 3 Testing and Evaluation, $700 million. Phase 4 Production and Deployment, $700 million. This budget covers essential costs including research and development, procurement of materials, and the establishment of testing facilities. Financial oversight mechanisms will be in place to ensure that the project remains on track and within budgetary constraints. Consistent themes across sources. Various reports and analyses highlight several key points regarding the F-47 project. The strategic importance of stealth technology in modern aerial warfare. The clearly defined timeline leading to the anticipated operational status by 2024. The integration of advanced materials and design techniques to achieve superior stealth capabilities. Divergent perspectives. While there is broad agreement on the project's structure and budget, some sources emphasize different technologies and methodologies that will be integrated into the F-47. For instance, some reports focus on the role of artificial intelligence in enhancing the aircraft's combat decision-making capabilities. Others highlight advancements in materials science that contribute to reducing the aircraft's radar signature. Timeline of events: 2021, preliminary research and feasibility studies conducted leading to project approval. 2022, official announcement of the F-47 project with initial budget allocation for Phase 1. 2023, transition from research to prototype development begins with the first prototypes expected by late 2023. 2024, completion of the testing phase and initiation of full-scale production and deployment. Conclusion: the F-47 stealth technology project represents a significant advancement in military aviation driven by a structured and well-funded development approach. With its focus on stealth capabilities and advanced technological integration, the F-47 is set to redefine the aerial combat landscape. As the project progresses through its phases, it is positioned to enhance the operational effectiveness of military forces by 2024, contributing to national security and strategic advantage in global military operations. This report encapsulates the critical components of the F-47 stealth technology implementation, providing a comprehensive overview of the project's phases, budget, and expected impacts on military aviation. Counterintuitive information in the implementation of F-47 stealth technology by 2024 includes the following insights. 1. Budget allocation versus technological complexity. While the $3.2 billion budget seems substantial, the complexity and rapid evolution of stealth technology might mean that this allocation could be insufficient. Historically, stealth projects have faced cost overruns and delays due to unforeseen technical challenges, suggesting that the initial financial commitment might not cover the entire scope of development and operationalization. 2. Research and design phase. It may appear that the initial research and design phase would predominantly involve high-tech simulations and advanced materials. However, a significant portion of this phase may actually rely on historical data and lessons learned from previous aircraft, indicating that innovation might not be as groundbreaking as anticipated and could be more about refinement than revolutionary change. 3. Prototype development timing. The expectation that prototypes will be ready by late 2023 could be optimistic. Historically, prototype phases often encounter delays due to technical issues or design flaws that surface only upon physical testing, suggesting that the timeline may extend beyond initial projections. 4. Integration of AI technologies. The assumption that integrating artificial intelligence will straightforwardly enhance combat decision-making may overlook the complexities involved. Effective AI integration requires extensive training data and real-world testing, which may not be fully achievable within the restrictive timeline leading up to 2024. 5. Stealth versus other capabilities. The focus on enhancing stealth capabilities may counterintuitively lead to trade-offs in other areas, such as payload capacity or speed. This could result in an aircraft that is stealthy but less versatile in combat situations, potentially undermining its overall effectiveness. 6. Public perception versus military necessity. There is a common belief that advancements in stealth technology are solely driven by military necessity. However, political considerations and public perception can also play significant roles in funding and prioritization, suggesting that the project may be influenced more by external factors than by purely technical requirements. 7. Phased approach. The structured four-phase approach implies a linear progression, yet in reality these phases may overlap or need re-evaluation based on testing outcomes, which could lead to unexpected delays or adjustments in the project timeline. 8. Environmental impact. While advancements in stealth technology are often associated with military superiority, the environmental impact of producing advanced military aircraft is frequently overlooked. The materials and processes involved in creating stealth features might have significant ecological footprints that could contradict the military's broader environmental commitments. In summary, while the F-47 project aims for significant advancements in stealth technology, various counterintuitive factors such as budget constraints, technological integration challenges, and external influences could affect its development trajectory and operational effectiveness. The implementation of F-47 stealth technology by 2024 is a complex and multifaceted project that encompasses 4 critical development phases and a substantial budget allocation of $3.2 billion. While the report provides a clear overview of these phases and the financial aspects, certain significant elements may be overlooked by many readers. Below are the important content areas that deserve more attention along with explanations of their significance. 1. Importance of aerodynamic shapes and materials. In the research and design phase, the emphasis on identifying effective aerodynamic shapes and materials is crucial. Readers might skim over the technical complexities involved in achieving a reduced radar cross-section (RCS), which is essential for stealth technology. The choice of materials, including composites that can absorb radar waves rather than reflect them, is significant. Why it's significant? The aerodynamic design directly impacts the aircraft's performance, including speed, maneuverability, and fuel efficiency. A well-designed shape not only enhances stealth but also ensures that the aircraft can operate effectively in combat scenarios. This technical foundation lays the groundwork for subsequent phases and ultimately determines the F-47's operational effectiveness. 2. Prototype testing as a feedback mechanism. The prototype development phase emphasizes building and testing scale models. This iterative process is vital for refining stealth features and performance. While many might recognize the need for testing, the significance of this phase as a feedback mechanism is often underestimated. Why it's significant? Testing prototypes allows engineers to identify weaknesses and strengths in design before full-scale production begins. It serves as a critical checkpoint to validate theoretical models against real-world performance, ensuring that costly mistakes are minimized. The data collected during this phase will influence design modifications and operational adjustments, which are essential for the aircraft's success. 3. Integration of advanced technologies. The report mentions varied emphases among sources regarding technologies employed in the F-47, particularly the role of artificial intelligence (AI). The integration of AI into stealth operations is a significant advancement that is often overlooked. Why it's significant? AI can enhance decision-making in complex combat scenarios, allowing for real-time data analysis and adaptive strategies. This capability can provide a tactical edge in aerial engagements, making the F-47 not just a stealth aircraft but also a smart one. Understanding the implications of AI on operational tactics and mission success is crucial for grasping the full potential of the F-47 project. 4. Financial oversight mechanisms. While the budget allocation is mentioned, the mechanisms for financial oversight and periodic evaluations might not receive adequate attention. Many readers may not realize how crucial these checks are to the project's success. Why it's significant? Effective financial oversight ensures that resources are allocated efficiently and that the project remains on schedule and within budget. It is essential for adapting to unforeseen challenges such as technological setbacks or changes in strategic military needs. This aspect is vital for long-term project sustainability and success, particularly for a project as ambitious as the F-47. 5. Strategic necessity of stealth technology. The emphasis on stealth technology as a strategic necessity in modern aerial combat is a point that often gets lost in technical discussions. While the report touches on this, the broader implications are significant. Why it's significant? In contemporary warfare, the ability to operate undetected is a game changer. The development of the F-47 signifies a shift in military strategy towards prioritizing stealth capabilities, which can influence global military balances. Understanding the strategic necessity helps contextualize why such investments are being made and how they could potentially reshape future conflicts. 6. Timeline implications for military readiness.
The timeline laid out for the project indicates a clear progression from research to deployment by 2024. However,
the implications of this timeline for military readiness and strategic planning may not be fully appreciated by all readers. Why it's significant: the successful and timely implementation of the F-47 could enhance military readiness and operational capabilities significantly by 2024. This could impact defense strategies, procurement policies, and international military relations, especially if adversaries are not advancing at a similar pace. The urgency of the timeline reflects the competitive nature of military technology development and the need for nations to maintain technological superiority. 7. Supply chain and manufacturing challenges. The production and deployment phase includes establishing manufacturing processes and supply chains, which is often a logistical challenge that receives insufficient attention. Why it's significant: the success of the F-47 project hinges not only on technological development but also on the ability to manufacture these advanced systems efficiently. Supply chain disruptions, material shortages, or manufacturing delays could significantly impact the project's timeline and costs. Recognizing these potential challenges is critical for understanding the full landscape of risks associated with the project. Conclusion: the F-47 stealth technology project represents a crucial advancement in military aviation, with its successful implementation poised to redefine aerial capabilities. However, as outlined, several significant aspects are often overlooked, including the importance of aerodynamic design, the role of AI, financial oversight, and supply chain challenges. A deeper understanding of these elements is essential for comprehending the full scope and potential impact of the F-47 project on modern military strategy and capabilities. By focusing on these overlooked details, stakeholders can better prepare for the challenges and opportunities that lie ahead in the implementation of stealth technology. The implementation of F-47 stealth technology, with a total budget allocation of $3.2 billion by 2024, encompasses several critical elements that merit in-depth analysis. Here are 4 of the most valuable points for further discussion. 1. Phased development approach. The structured 4-phase development strategy is a cornerstone of the F-47 project. Each phase builds upon the previous one, allowing for iterative refinement and risk reduction. In-depth analysis: this approach ensures that potential issues can be identified early in the process, particularly during the research and design phase 1 and prototype development phase 2. The systematic transition from theoretical designs to practical prototypes allows engineers to test and modify concepts based on empirical data. This mitigates risks associated with full-scale production and could lead to enhanced performance metrics, ensuring the F-47 meets or exceeds operational requirements. 2. Budget allocation and financial oversight. The allocation of $3.2 billion across the development phases is not only a testament to the project's ambition but also highlights the financial strategies necessary for such an undertaking. In-depth analysis: this budget must be meticulously managed to ensure that resources are allocated efficiently across research, materials, procurement, and testing. Financial oversight mechanisms will need to be robust, with regular evaluations to maintain accountability and adaptability. Understanding how funds are allocated to specific technologies or materials can provide insights into prioritization within the project. For instance, significant investments in advanced materials could indicate a strategic focus on enhancing stealth capabilities, whereas funds directed towards AI integration might suggest an emphasis on operational effectiveness and situational awareness. 3. Technological integration, materials, and AI. The emphasis on integrating advanced materials and artificial intelligence (AI) into the F-47 design is crucial for achieving superior stealth and operational capabilities. In-depth analysis: the selection of materials that minimize radar cross-section (RCS) is vital for the success of stealth technology. Analyzing different materials' properties and their impact on performance will be important in Phase 1 and Phase 2. Furthermore, the incorporation of AI could revolutionize how the aircraft makes real-time decisions during combat.
This could include automated flight adjustments, threat detection, and even tactical planning.
A deeper exploration of how these technologies synergize could reveal the F-47's potential advantages over existing aircraft, particularly in contested environments.
4. Strategic implications of stealth technology. The F-47 project is emblematic of broader trends in military aviation,
particularly the increasing importance of stealth capabilities in modern warfare. In-depth analysis, the strategic necessity of stealth technology in aerial combat is underscored by evolving threats and adversary capabilities. Engaging in a discussion about how the F-47 fits within the larger context of military strategy can illuminate its potential impact on future conflict scenarios. This includes examining how the F-47's capabilities may alter air superiority dynamics, influence enemy tactics, and shape defense policies. Additionally, the implications for global military balance and the arms race in stealth technology could be significant, warranting a comprehensive evaluation of geopolitical consequences. In conclusion, the F-47 stealth technology project represents a multifaceted approach to advancing military aviation capabilities. By exploring the phased development strategy, budget management, technological integration, and strategic implications, a deeper understanding of its potential impact and challenges can be achieved. 1. The Manhattan Project 1942–1946. The Manhattan Project was a secret U.S. government research project during World War II that developed the first nuclear weapons. It involved multiple phases, including research and design, prototype development, testing, and eventual production. With a budget of around $2 billion, equivalent to over $25 billion today, the project brought together some of the greatest scientific minds of the time and resulted in the creation of the atomic bomb, which was used in Hiroshima and Nagasaki. 2. Apollo Program 1961–1972. The Apollo program was a series of missions undertaken by NASA with the goal of landing humans on the Moon and bringing them safely back to Earth. This program included several key development phases: initial research, design, and testing of spacecraft like the Saturn V rocket man missions,
and lunar landings.
The budget for Apollo exceeded $25 billion, over $150 billion today, and it successfully achieved its objectives, with the Apollo 11 mission in 1969 marking a significant milestone in human space exploration. 3. Joint Strike Fighter JSF Program 1996–present. The Joint Strike Fighter program, which led to the development of the F-35 Lightning II, is one of the most significant military aviation projects of the modern era.
It has involved several phases, including research, design, prototype testing, and production.
The budget for the JSF program has exceeded $400 billion over its lifespan, making it one of the most expensive military programs in history. The F-35 incorporates advanced stealth technology and is designed to perform various roles for the U.S. Armed Forces and allied nations. The implementation of the F-47 stealth technology by 2024 is not just a pivotal moment for military aviation but also a potential game-changer in the broader context of defense technology and aerial combat. With a budget allocation of $3.2 billion distributed across 4 development phases, the future outlook for the F-47 project is promising, with several key predictions shaping the trajectory of military aviation. Predictions for the future. 1. Enhanced stealth capabilities. By 2024, the integration of advanced stealth technology is expected to set new benchmarks in radar evasion. The F-47 will likely employ innovative materials and design techniques that significantly reduce its radar cross-section (RCS).
This will lead to a paradigm shift in aerial engagements, where aircraft can operate within enemy airspace with minimal detection risk. 2. Artificial intelligence integration. The use of artificial intelligence (AI) is anticipated to play a crucial role in the F-47's operational capabilities. Future iterations may incorporate AI to enhance decision-making in combat scenarios, enabling real-time data processing and adaptive tactics.
Such integration is expected to improve situational awareness and responsiveness, making the F-47 a formidable asset in multi-domain operations. 3. Collaborative combat operations. The F-47 is likely to be developed with a focus on interoperability within joint task forces. As military strategies evolve towards network-centric operations, the F-47 will probably be designed to share intelligence and coordinate with other platforms, including drones and ground forces. This collaborative approach will enhance mission success rates and overall combat effectiveness. 4. Global military market influence. The successful deployment of the F-47 stealth technology may influence global military procurement trends. Countries observing the U.S. advancements may seek to develop or acquire similar capabilities, leading to a potential arms race in stealth technology and aerial combat systems. This could drive innovations in defense technology across various nations, reshaping the global military landscape. 5. Investment in supporting technologies. The focus on the F-47 is expected to spur investment in supporting technologies such as advanced radar systems, electronic warfare, and counter-stealth technologies. This ripple effect will lead to a more comprehensive modernization of military capabilities, fostering advancements that extend beyond just the F-47 program. 6. Challenges and adaptations. While the F-47 project is on a positive trajectory, it will face challenges, including technological hurdles and budgetary constraints. The military must remain adaptable, ready to pivot strategies and technologies based on testing outcomes and evolving threats. Continuous evaluation will be essential to ensure that the F-47 meets its ambitious goals. 7. Sustainability and maintenance innovations. As military operations increasingly prioritize sustainability, future developments of the F-47 may include innovations in maintenance and lifecycle management. The integration of smart technologies for predictive maintenance could lower operational costs and increase the aircraft's availability and readiness. 8. Public and political perception. The F-47 program will also need to navigate public and political landscapes. As defense spending and military projects face scrutiny, effective communication about the benefits and strategic necessity of the F-47 will be vital. Building public support through transparency and engagement will help secure future funding and sustain the project's momentum. 9. Long-term strategic impact. Ultimately, the F-47 stealth technology is expected to redefine the strategic balance in aerial warfare. As nations adapt to the enhanced capabilities of stealth aircraft, traditional combat strategies may become obsolete, necessitating new doctrines and training for air forces worldwide. 10. Evolution of military doctrine. The introduction of such advanced stealth technology will likely necessitate a re-evaluation of military doctrines. Air forces may shift their focus towards asymmetric warfare strategies, leveraging the F-47's capabilities to conduct operations that minimize direct confrontations with adversaries while maximizing strategic advantages. Conclusion. The future of the F-47 stealth technology by 2024 is characterized by several transformative predictions that reflect broader trends in military aviation and global defense strategies. With its ambitious development phases and substantial budget allocation, the F-47 project is poised not only to enhance the capabilities of the armed forces but also to influence the trajectory of military technology and international relations in the coming years. The successful implementation of the F-47 could mark a turning point in aerial combat, shaping the nature of warfare for decades to come.